Hey, how's it going? Welcome back to the channel. And as you can see, we have an interesting looking small Sudoku. Well, it's technically not a Sudoku, it's a set of Sudokus. I guess they have a correlation to each other, so we can say they are one homogeneous Sudoku. But let's get into our rule sets and see if that is actually the case, because I have not looked at these rules, so I don't know exactly how these things interact with each other. So, all that said, this is called Twin 4's by Thermometers. Let's look at these rules and see what we can figure out for this puzzle. So we've got place 8 of the digits 1 through 9 into the Sudoku grids. Digits cannot repeat in any column, row, or 2x2 box, and the left puzzle and right puzzle each have 4 unique digits. Now let's think about that for a second, because I'm not sure I 100% understand if that's limiting us in certain ways or not. But let's move on with the rules, and then we'll try to figure it out in the actual puzzle. So we also have digits on an arrow sum to the digit in that arrow circle. So like these two digits right here, whatever they sum up to would equal this. And then we also have digits increased from the bulb of a thermometer. So this thermometer, it's a little stubby guy, but it's going to do something, I guess. We have a lower digit and a higher digit, essentially what this is saying. Those are the rules. Now, let's get into this one and see if we can flush out the specifics of this first section of rules. Because I think I need to think about it for a second to see if there's anything inherent in it that says one thing or another has to occur. Now, it says digits cannot repeat in any column, row, or 2x2 box. Now, I would take that to believe that if you had a digit in here, it could not repeat over here, because this is a row. They're separated, they're still in a row. Now, there are other puzzle types where there are blank sections in between certain regions, and they do still count towards that. So I think that's what I'm going to roll with for now, until I decide otherwise. The left puzzle and right puzzle each have 4 unique digits. So if they each have 4 unique digits and we have to place 8 of the 9 digits, that to me states that there has to be 4 unique digits here and 4 unique digits here. There cannot be an overlap between the two in terms of digits. Okay, I think that makes sense. Does that make sense with you? I don't know. But that seems to be the most logical way to look at it and to understand it in my mind. Now, can we start making some assertions as to what is going on here and which digits are which? So we said we have to pick 8 of the digits 1 through 9. So we're going to have one digit that does not exist in this puzzle at all. We have, well, looking at this arrow, we have a 3-cell arrow. So we have to have, and they're seeing each other, so they have to be unique. So they have to be at the very least 1, 2, and 3, which would equal 6. So we know this has to be at least 6, 7, 8, or 9. Now, does that tell us anything? We can't use the same logic here, because we could technically have these two digits be the same digit, because they don't see each other in the Sudoku. Well, okay, I think I need to start coloring. I think that's where this is going to go to. So we've got this digit. Let's put a color on it. Let's say green. Now we know none of these can be green because they're in the same box. Now this green sees both of these digits, but it also sees this digit, because this digit and this digit can never be the same digit, because you'd have that same digit and you'd have to have 2 other digits add up to equal the same digit. So it'd have to be like a positive and a negative digit. That doesn't work. So this has to be the green digit. And therefore, one of these 2 sets has to be that green digit. Okay, maybe we need to just color all of these and start looking at what's what. Okay, yeah, doing that it becomes obvious to me. Sometimes I can be very visual. I have to see it and to be able to, or have the colors or what have you put in front of me. This digit and this digit have to be the same digit. First off, because there has to be 3 separate digits plus this digit, which is already 4 unique digits. So there cannot be any more unique digits. And also when this one's looking here, and this one can't be green, obviously, so it has to be here. So now we know we've got a yellow digit plus, well, it can't be a green digit here. I think that's something we can also say, because this is the highest digit, no matter what we put into any of these cells. This is the highest digit because it has 3 smaller digits equaling up to it. So therefore, this can't be the green digit, because it has to be the highest digit possible plus some other digit to equal a digit that can't exist. So this is green, okay? And then we can look back here and say this is green. Now we can just go through, say this is blue. Blue cannot be added to itself and equal itself, or add to something and equal itself, so this has to be blue. The yellow now has to go here. This has to be purple, purple, blue, purple, and yellow. Okay, so we've got some coloring done fairly easily, I would say, on that. Now, what can we figure out from this? Like I said, we know we have 3 digits that equal this, so this is always the high digit. One of these is going to be a low digit. It's going to be the lowest digit. One's going to be the second, another one's going to be the third, and this will be the fourth. Now, we know blue is a lowish digit because it's on the bulb of a thermo. So we know yellow is always higher than blue. In fact, we know that purple is going to be higher than blue because blue plus yellow is going to equal purple. So purple seems to be the next digit down in terms of the highest, because we've got these 2 digits adding together to equal it. And we know blue is the lowest digit because it is lower than yellow because of this thermo. So what can blue possibly be? Well, it could be 1 or 2, I guess. It can't be 3, because if it was 3, these 2 digits would have to be higher than 3. So you'd have the bare minimum would be 3, 4, 5, which is 12, which breaks it. So only 1 or 2 seems to work in the blue world. Now we're going to have some digit in yellow that is higher than 1 or 2. So let's put in 2 or 3 for now. Could it ever be a 4? If this was a 1 and this is a 4, this has to be higher than both of them. This would have to be at least 5, so that would make 10 here, so that can't work. So 2 and 3 seem to be the only possibilities there as well. Now let's look at purple, I guess. Now purple has to be higher than 2, so it could be 3 or 4. Could it be 5? 5, 6, 7, 8, or 8, 9. Looks like it could be 5, so let's put 5 in. Now, what can we figure? We know that it goes blue, yellow, purple, green. So if this is 1, 2, 3, this would equal 6. These would be 1 and 2, and this would equal 3. That would correlate to that. If this is 1, 2, 4 to equal 7, I think it breaks this, because you'd have 1, 4, or sorry, 1 and 2 would have to be equaling 4, which doesn't ever work. So this can't be 7. I think we can rule that out. Now, this was 1, 2, 5. That doesn't work. Wait, let me just make sure I didn't make a mistake there. This can't be 1, 2, 4 is all I'm saying. 1, 2, 4. If it was, it would break this, so this can't be 7. So that is correct. If this was, this can't be, if this is 1, 2, it has to be 3. That's the only option. Now, if this was 1, 3, this could be 4, because this would be 1, 3 here, and they would equal 4. Now, if this was 2 and 3, 2 and 3, or 2, 3 that way, these would equal 5, and those all work. So 6, 8, and 9 all seem to work. Now, is there anything else I can say about this at the moment? I don't think there is. It seems to be kind of stuck here for now. So maybe I need to go over here, and there might be something that's going to look back over here and start determining something. So I know, what do I know? 2, 3, 2, 3, 4 works, right? 2, 3, 4. 3, 2 and 3 would, wait, that doesn't work, sorry. I was looking back again. If this is a 2, this has to be a 3. But this could be the 5, okay. So this could still be 1 or 2. Okay, I just taking a quick look back there, I thought I might have seen something. I did not. So do we know anything about this? Well, is it possible that these could be 3 different unique numbers? And the answer is, if these were, let's say, 1, you couldn't do 1, 2, 3, because it would rule out everything else on the side. You couldn't do 2, 3, 4, because it would rule out everything yellow. And then you'd have the same issue of both of these would have to be 9, but we know we have to have 8 unique digits. Can you do something like 1, 3, 4? Which would make this equal 8. If it's 1, 3, 4, no, 1, 3, 4 doesn't work either, because you'd be forced to put both of these as a 2. So what if these were 1, 3, 5? It does the same thing. You'd have both of these equaling 2. So I don't think you can make these 3 unique digits, I think is what I'm saying here. Because it seems like it breaks everything that happens over here. So let's say these are their own digits, and look at it that way. Now, they have to be semi-small digits, because the highest we can ever get to is 9. So if these are both 1, you know, this could be a bunch of things. These are both 2, this could still be a couple things. These are both 3s, this would be at most, you know, a 1 or a 2. These could technically both be 4s, I guess, as well, and this could be 1. So these could be from 1, 2, 3, and 4. That's not helpful at all. And the oranges don't tell me anything on this side. So maybe there was more I could do over here. I just didn't see it quite yet. If the blue was a 1, there could be multiple things that happen. Can we rule out a 2 maybe from yellow? Because if yellow is 2, that forces blue to be 1. And it forces purple to be 3. That all works. So I don't think so. Now, if purple was 3, it just forces the exact same thing then. So that's 3. These have to be 2 and 1. This equals 6. 2, 1, and 3. Purple was 4. We've got, I guess, a couple of options there. Again, 4x4 is not necessarily an obvious and quick solution. So maybe I do need to look further at this. Now I said the highest these can go to is 4. If these had 4s, this would have to be a 1, and this would have to be a 9. Let's just roll with that for a second, just to take a quick look to see if that breaks anything. We would be forced to put 2s in all of these. We would be forced to put 3s in all of these. And we'd be forced to put 5s in all of these. So we'd have 2, 3, and 5. That equals 10. Yeah, so that doesn't seem to work. Because there'd be no other way to set this up if we got 2 4s. This would have to be 1 to equal 8. So let's remove 4 from this as a possibility. So now we've got 1, 2, and 3. So we've got a triple, essentially, determined. One of these is 1, one of these is 2, and one of these is 3. So none of these could be 3. Now, if that's the case, this can never be a 6. because the only way to make a 6 would be 1, 2, 3 like that. So this is not 6. So we're down to 8 and 9. Then, because we can remove a 3 from here, does that help us further? Once again, 1, 2 cannot equal 4, and 1, 2 cannot equal 5. That's a correlation between these two. So whatever these two equal or add up to has to be this. So it cannot be 1, 2. It can't be a combination of 1 and 2, which means this can never be 2. Because if it was, it forces this to be 1. So these are 3. So these are not 3. We get a doot in the corner. Now, these can still be 2, 3, 4 to equal 9. And 3 and 2, no, that doesn't work. Because if it's 2, 3, 4, that would equal 9. The 2, 3, 4 means that 2 and 3 would go here, but they'd have to equal 4. They equal 5. And can we ever get, we can get to 9 otherwise. Okay, let me think about that one more time, just make sure I've got my logic straight. We know we've got 3's in here. This is either 1, 2, or 1, 3 that equals 4. And if 1, 3, and 4 is 8, we can't do, we said 2, 3, 4, that breaks. Can we do 2, and we can't do 2, 3, 5, because that breaks, because we get 5, 3, 8, or 8, geez. 5 and 3 equals 8 plus 2 is 10. So I have to say these cannot have a 2 in them because they break the puzzle. So we have to have 1's, which means these have to be 2's in correlation. Now the purples therefore have to be 4's. And now we have an 8 situation in all of these. Okay, that seemed to work. Let's continue to see if it does. I'm going to remove, now let's leave the color in there for now. So now we know we've got at least 4 plus some other digit, which can't be 1, 3, or 4. So this has to be a 5, which means this has to be a 9. So we've got 2, 2, 5, 9. The 5 is going to have to go in here. What else do we have? We have to have one more digit. It cannot be 1, 2, 3, 4, 5. It has to be either 6 or 7. Something about that doesn't quite look right. But no, it works. It does work. Okay. What I was worried about is putting a 6 and 7 here. That would clearly break. So let's color this. Let's make it gray. So that has to be gray up here. Well, no, it doesn't. Sorry. This has to be gray up here. This has to be 6 or... I'm not going to put the 6 or 7 in, but this has to be 9 because just a basic Sudoku. Now, this has to be... It can't be 6 or 7 because it breaks. So it has to be either 2 or 9 or 5. It can't be 5 because it breaks, so it's either 2 or 9, and it can't be 9 because that would break it, so this has to be 2, which means this has to be 7, which means these have to be 7. Let's color and color. Now we know this has to be 9, this has to be 5, this has to be 9, this has to be 5, this has to be 7, and I'm going to do a quick coloring before I finish. Let's put something to there. We'll leave the 9's as white, and this has to be a 2. And there we go. We solved the puzzle. Solution is correct. So, like usual, going into 4x4s or anything, let's color that one. I missed it. Sorry about that. Going into a 4x4, they're not always as easy as they first look. There is quite a bit of thought that had to go into this one to make it, to figure out where things worked out. Otherwise, a lot of fun. Always enjoy Sir Moose puzzles. Hope you did as well, and I will see you in the next one.